Let's go to page 42. This is lesson 1.6, and the objective of this lesson is to classify polygons. Okay. So first, let's go over the key concept to identify polygons. Okay, over here, it says a polygon is formed by 3 or more line segments called sides. So a polygon has 3 or more sides. Okay, and next is that each side intersects exactly 2 sides, one at each endpoint. So this would be example of that. Okay, and each endpoint of a side is called a vertex. So this is called a vertex. So the pentagon has 5 vertices, okay, or vertices. And a polygon can be named by listing the vertices in consecutive order. For example, like A, B, C, D, E. Okay? Or if you start with C, then it will be C, D, E, A, B. Okay? Now, again, when you name it, you must be consecutive. You cannot jump all over the place. You cannot go C, A, E, B, D, for example. That would be incorrect. Okay? As long as you go in clockwise or counterclockwise, or you can start with any point and make sure that you go consecutive. So that's how you name the polygon. Okay, the next thing is the classification of convex and concave. Okay. So convex is when no line that contains a side of the polygon contains a point in the interior of the polygon. A polygon that is not convex is called a non-convex or concave. So what this means is that if you will extend the side, okay, notice none of the line will go through the inside of the shape. So that is convex. The concave is when you draw the line, it will go through the inside of the shape. Okay, so you just extend each side. And another way to remember is think about the cave. Okay, think about one of the sides cave in. Imagine that this is straight, it got cave in. Okay, that's an easy way to remember the concave. Okay, when there's a dent is bent inside, it caves in. One of the sides got cave in, and that's a concave polygon. Okay, let's go to example 1. Example 1 tells whether a figure is a polygon and whether it is convex or concave. Okay, so A, this is not a polygon, okay, because some segment intersect more than 2 segments. Okay, it's like this one over here. Like this segment intersect 1, 2, 3, 4. Okay, so it's not a polygon. Okay. B, this is a polygon because each side or each segment only intersect 2 other segments. Part C, this is not a polygon because one of the sides is not a segment. Okay, see this side is curved. Segment is straight, right? So this is not a segment, so it's not a polygon. D, this is a concave polygon because if you were to draw this line straight, see if you were to draw this side, extend this, it goes to the inside. Okay, so this is a concave polygon. Okay, now let's go to page 43. That's how you name the polygon. So number 3 sides is called triangle. Okay, triangle because when you have 3 sides, you have 3 angles. Okay, so tri means 3, angle means it forms by 2 rays, right, or 2 sides. So triangle means a shape has 3 angles, so again, that's a triangle. Now 4, when you have 4 sides, it's called quadrilateral. Quad means 4, lateral means side, so it means 4 side. Okay, so number 4 side. Okay, now 5 side is called pentagon. Again, the prefix penta is 5, hexa is 6, so hexagon is 6-sided. So if you know the prefix, then you can kind of know how many sides is it. So hepta is 7, so heptagon is 7-sided. Okay, octa, so that's the 8-sided. 9 is nonagon, 10 is decagon, 12 is dodecagon, and after that, if more than that, you just call n-gon. Okay, so if it's 13-sided, it's 13-gon. Okay, so it tells that. Okay, now next one is equilateral polygon says in the equilateral polygon, maybe means equal means same, lateral means side, so equilateral means all sides are equal. Okay? So all sides are congruent. Now over here, equiangular, again means same, equal, angular means angle, so equiangular means all angles are congruent. Okay? Now when you combine this together, a regular polygon is a convex polygon that is both equilateral and equiangular. Here's an example of that. Okay. Now let me give you more example. Okay, so for example, if you have a rectangle, is equiangular, okay, because all angles are equal. So it's equiangular, but it's not equilateral. Okay? If you have a rhombus, okay, this one is equilateral, but it's not equilateral, but it's not equiangular. Okay, see that? Now, if you have a square, when you have a square, okay, so this one is equilateral, is also equiangular. Okay? Therefore, it is regular polygon. Okay? So you can see the difference between the three. So this one is equiangular, all angles are equal, but it's not equilateral. The sides are not equal. The rhombus is equilateral, all four sides are equal, but the angles are not equal. Okay, so it's not equiangular. Okay? Now when you combine this together, okay, when you have a square is equilateral, all sides are equal, and also equiangular. Okay? And therefore it's a regular polygon. Okay. Okay, let's get back to example 2. Example 2, it says classify the polygon by the number of sides. Tell whether the polygon is equilateral, equiangular, or regular. Explain your reasoning. So A, okay, this polygon has 6 sides, 1, 2, 3, 4, 5, 6, right? And see the marking, it tells you that this is equilateral, okay, all sides are congruent. This is also equiangular because all angles are congruent by the marking. So therefore, this is a regular hexagon. Okay, this has 4 sides. Okay, and notice that these two are congruent. These two are congruent, but they are not equal. Okay, so this is not equilateral. Okay, because these two are not the same. Also, look at the angles. Okay, these two are congruent. These two are congruent, but they are not equal. So this is not equiangular. Okay. So this is not a regular polygon. This is a parallelogram. Okay. Now if you go C, okay, again you count it. These are 12 sides, so it's a dodecagon. Okay, and the sides are congruent, so it's equilateral, but all sides are congruent. And if you look at the angle, okay, see all the angles are congruent, so this is equiangular. However, the polygon is not convex, so it's not regular. So again, so another requirement for a regular polygon is it have to be convex. Okay, it cannot be concave like that. So when it's concave, it's not regular. Okay, let's go to example 3. Okay, example 3, you have a table that is hexagon. And this is 3x plus 6. And this is 4x minus 2. Okay? So the problem, it says a table is shaped like a regular hexagon. Again, regular means it's a convex and all 6 sides are congruent and all 6 angles are congruent. And you want to find the length of the side. Okay? So because this is a regular hexagon, so every side is equal. So that means this is equal to that. So if you set your equation, so you got 3x plus 6 equal to 4x minus 2. Okay? Now all you have to do is solve the equation. Now, since the higher numbers over here, so that's going minus 3x on each side. You can go down, so you got 6 equal to x minus 2. Now, plus 2 on each side, so do a little bit of algebra, so x equal to 8. So once you find x equal to 8, you can substitute into either one of these to find the length. Okay? So that's it. If you substitute into here, so you got 3 times 8 plus 6 equal to 24. Plus 6 equal to 30 inch. Okay? If you were to substitute into here, you're going to get 4 times 8 minus 2, so equal to 32 minus 2 equal to 30 inch. Okay? So again, it doesn't matter which one you substitute because they're equal, right? Okay, so you can substitute into either one and you should get the same answer. Now you don't have to do both. I just do the both to show you that you can do it either one.